Okay, hi Chem 30. This is the second lecture in the organic chemistry series. It's not going to be super long. I'm just going to talk about alkanes. So we're going to start to name hydrocarbons. I gave you an introduction in the last lecture. Just to let you know, I'm going to have to stop and start this a few times just because I've got to check in with my phys ed class. But first thing we should look at is what organic compounds are. So organic compounds are broken into two main categories: hydrocarbon derivatives, which are synthetically produced by humans. So they are hydrocarbon that's altered. Okay, we're going to talk about halogenated hydrocarbons or organic halides. We're going to talk about alcohols. I mean, some alcohols are produced naturally through fermentation, but most of them are produced through industrial processes. Acids, same deal. Esters, same deal as alcohols and acids. So a lot of these do occur naturally, but most of them are synthetic production. Okay, so hydrocarbon derivatives, so modifications of long hydrocarbon chains, and hydrocarbons themselves. So you need to know this term aliphatic and aromatic. So these are unadulterated hydrocarbons that we pull from living organisms and fossil fuel resources. They're divided into two main categories. One is aromatic, meaning the hydrocarbon has benzene, so therefore it will have a scent, or aliphatic hydrocarbons that have no benzene. Okay? Now, if you look on your organic nomenclature assignment, so you should have this up and with you as I go through these lectures, you should be able to answer question 1 from that. So I'm going to talk about alkanes today, but alkenes and alkynes are just modifications of alkanes. They have double and triple bonds, and alkanes have single bonds. So that should answer question number 2. There's double and triple bonds in the alkenes and the alkynes, and therefore not all the possible bonding positions on the carbon molecules are occupied by hydrogen. So you have some carbon-carbon double and triple bonds. All right. I'm only going to talk about alkanes in this lecture, and I'll do alkenes and alkynes in another lecture. So when we look at alkanes, I'm going to flip to this. So alkanes only have single bonds. So they have hydrogen occupying all possible open bonding spots. The carbons are bonded with single bonds. So the C to C bonds are bonded with single bonds. Anytime you have a saturated hydrocarbon, it ends in A and E. So the prefixes and the suffixes are going to be really important for organic chemistry. This is also in your organic nomenclature assignment. What is the chemical formula for alkanes, alkenes, and alkynes? So the formula generally is Cn, so the number of carbons, all right? So N is the number, and H, 2 times that number plus 2. So if I look at ethane, I already gave you ethane in a previous example as well, but if I look at ethane, C2H6, there's 2 carbons and 6 hydrogens. So if I look at CnH, 2 times N plus 2, that, and N equals 2, that's C2H 2 times 2 plus 2. So that's going to be 4 plus 2, so that's C2H6. So if you know the number of carbons through this little algebraic formula underneath the hydrogen, you'll know the number of hydrogens, all right? So you should be able to answer that for alkanes on your organic nomenclature assignment as well. When we look at hydrocarbons, hydrocarbons can be continuous chains. So they can be one simple chain or branch. So I'm going to look at simple alkanes and branched alkanes today. We have the main thing that you're going to learn from this unit is how to name different compounds and how we connect different types of hydrocarbon molecules to fossil fuel production in Alberta and human use, not just in Alberta but worldwide, and what are a lot of these uses of organic compounds and what are the origins of them, right? So we already kind of introduced that when I introduced the lecture on fossil fuel, the fossil fuel industry, with the first organic chemistry lecture. So alkanes have single bonds. If you have alkenes, they have double bonds, and alkynes have triple bonds. Hydrocarbons need a prefix and suffix. The prefix indicates the number of carbon atoms present, and the suffix indicates the family of organic molecules we're identifying. So the end part, so if I look at this is an alkane. Right? The suffix itself tells me what type of molecule it is. So ANE would be single bond, ENE is double bond, YNE is triple bond. You're not going to need to name molecules above 10. All right? But carbon chains up to 10 you need to know. Now, if you were in Science 30, you would be given a chart with this. But in Chem 30, you need to learn and memorize this. So for a continuous train, this is also called a homologous series. So a homologous series is a sequence of molecules of similar structure that differ only in the number of repeating units. Okay? So these all have similar structures, but they have a different number of carbons each. We're just going to have to pause that for a second.